intro. So, why are we talking about code reading? Right, the product we produce is written code, which is correct. You know, as an industry, you know, the focus, education, all that is about producing functioning code that's fun. You get to see something happen. This is what we produce value with, is our executable code. However, as professional engineers, I think the estimate is somewhere around 70% of your time is spent reading, not writing code. And so, you know, I think that says something terrible about the state of education in our industry, that, you know, we focus on producing high quality code or reusable code for efficiencies, but we don't think about increasing the efficiency in which we read code, which we spend most of our time doing. So I like this definition of good code. So what is good code? My favorite definition of good code is readable code. Good code is readable. And, you know, this is kind of a classic comic. You know, how many WTFs per minute is a measure of code quality. What I want to point out about this slide is that what good code is, by this definition, is subjective. It is how those people in that room are able to read that code. How many WTFs per minute do those people produce? So imagine you're on a team and you're all you all do code reviews, and, you know, you all understand what's going on. You have conventions and, you know, things kind of run smoothly. You bring a new person on the team. That new person, maybe they're junior, maybe they're fresh out of school, their ability to kind of understand what you guys are doing is quite low. So their internal WTF per minute may be quite high. And I just want to bring that up, that, you know, code quality, if you think about it in the definition of readability, is a subjective measure. And also, what I like about this definition is we define code quality by how readable it is. Then if we want to increase the code quality in the world, all we have to do is increase our own skill in reading code. So that's kind of the thesis that I'm going for. We're going to make more good quality code by increasing our ability to read code. We spend 70% of our time reading code. What the fuck? We should do a better job reading code. All right, so I want to just kind of, a lot of inspiration for this talk came from how educators think about reading comprehension. So I'm going to read through these. These are from a teacher's perspective, teaching reading comprehension to students. And I just want you to think about how many times either you yourself or you have seen or witnessed these sort of things as they relate to software. He seems to focus on the wrong aspect of a passage. For example, he concentrates so much on the details that the main idea is lost. She can tell the outcome of the story, but cannot explain why things turned out that way. He seems to have a weak vocabulary, i.e., maybe they don't know what a guard statement is, or different things that we might consider software vocabulary. She cannot tell the clear logical sequence of events in a story. How many times have you been sitting down, working on a piece of code, not able to make sense of it, and then you do a sequence diagram and things were clear? He does not pick out key facts from informational text. RTFM. He cannot give you a picture of what's going on in a written passage. For example, what the characters look like or the details of where the story takes place. You know, what's the mental model that you yourself or you've witnessed other people kind of bringing up that's like just so wrong? So what are we going to talk about today? We're going to talk about reading comprehension. We're going to talk about reading comprehension and code reading. We're going to talk about the differences between reading and code reading. Talk about some strategies for reading comprehension, some strategies for code reading, how to workshop these ideas, provide some code, and where we go next in the industry. So I'm going to take a step back. We're going to talk about one of the tools that educators and academics have that use for thinking about reading comprehension. So this is the Scarborough rope model. And the idea with the Scarborough rope model is that it's split up into two main strands of a rope, and each of those main strands have many different strands. And as a reader becomes more proficient in these different pieces, they're going to be able to comprehend better what's there. So it's split up into two main sections, word recognition and language comprehension. So word recognition what's called increasingly automatic. So this is more about what your brain does behind the scenes. And this does not apply so much to what we do in software, because at this point, all of you are fairly automatic with this already. And then language comprehension is strategic. So what strategies are readers using to comprehend what they're reading? So word recognition, things like, you know, can you understand what the syllables are in a word? Decoding is your ability to maybe sound out or understand a word you've never seen before, and also, you know, kind of what the alphabet are. Like dyslexic people have a really hard time decoding, for example. Sight recognition is like, how fast does your brain, like how many milliseconds does it take for your brain to recognize a word? So, you know, unfortunately, I really wanted to map those back to programming, because, you know, decoding is, you know, we talk about coding, encoding, decoding, but they don't quite map, because they're really about, you know, more about brain function. Language comprehension, however, I think, you know, it's really easy to see some similarities between code reading comprehension. So I'm just going to zip through these. So language comprehension, background knowledge. So that is facts, concepts, other things that you come to the table with. What's really interesting about background knowledge is how central it is to comprehension. And I suspect that this is similar for code reading as it is in literature. But studies showed that, you know, even if you were a poor decoder, you had a lot of background knowledge, your language comprehension would be much better than somebody who was a really good decoder but had poor background knowledge. Vocabulary is, you know, what we think of vocabulary. Language structures is syntax, semantics. So how, you know, what does a comma mean? What does a colon mean? Period. How do words fit together? Verbal reasoning is inference and metaphor. So your ability to kind of get the underlying meaning of what the author is trying to say, not what they're explicitly trying to say. And there's a whole category of things that are called literacy knowledge. So print concepts. So if you see a bolded word, you know that that means emphasis, or italicized, or genres. Like nonfiction, you'll have a different idea of understanding what you're reading if you know that it's nonfiction or fiction, and this especially applies to things like satire. So if you don't know what satire is, but you're reading satire, you're going to be really lost. So I wanted to map these ideas back to code. So the Scarborough-Rope model is on the right, and how I think they fit into coding is on the left. So if we talk about background knowledge, I think that relates really heavily to what's our domain? What's the domain that you're working in? And what's the application environment? So, you know, is this a web server? Is this a client application? And those bits of background knowledge are really key to, I think, us being able to understand what we're working on. It makes a big difference if you're coming to read a code base and you know that we're talking about the video domain, and you know a lot about the video domain, so you might know what to expect, what's coming next. Vocabulary. Vocabulary thing is something that people talk a lot about. So in here, I also put domain. I put domain in here because in software, we invent our own vocabulary. So, you know, JUnit Builder Factory that's not a real word. You know, but that is a real word for that program. Design patterns, I think, are another bit of vocabulary. So that you know what a factory is, that you can see this chunk of code and you're like, oh, that's a factory, that's a guard statement. Different ideas of abstraction. I think this is also part of the vocabulary of being a programmer. If you kind of don't quite understand what abstraction means, or, you know, what inheritance is, you're going to have trouble kind of getting past that. Encapsulation, guards, data structures, coupling, etc. There's like a whole slew of things that are, you know, considered vocabulary. Language structures. You it's pretty straightforward. This is, language syntax. I also added function in here. And one of the big differences, I think we need to keep in mind if we're comparing code and literature is that code is also executable. So that not only that you can read, var a equals, 12, you can read that. You also know what that means. That means that, there's something with the value. It's not a good example. So verbal reasoning, understanding the intent. In software, we are writing software, and as authors, we are communicating intent. And you can have the same piece of software that, returns the same value, has the exact same behavior, but it could be written in infinite number of ways. So what that means is, for you to understand this piece of software, you need to try and understand some of what that intent is. So this is sort of the analogy to inference and metaphor. What's the author trying to get at? Why did they write it this way? And then literacy knowledge, I put here, kind of like with print concepts and genres, what are the big application design patterns? So, is this, an n-tiered application? How is it structured? What are the big ideas? Is this MVVC, or, what other kind of big architectural patterns might be used? So I think it's important to talk a little bit about the differences between reading and code reading. So fundamentally, code is really different than literature. So one of the major differences is we're looking at a machine in state through time. There's no corollary for a written book. Also, the execution of that code can be critical to your understanding of it. I think it's not enough just to read that source code. Sometimes you need to go look at the stack. You need to be able to see how the execution is running for you to really understand what's going on. Unlike books, code is nonlinear. There is no start and end of a piece of code. If you're trying to read a piece of code, you're probably trying to say something like, I want to add a button, or I want to make a button do something. And so you might go look for another button that does something similar and try and understand what that entry point to that piece of software is. But what that means is, your entry point to reading is not like in a book. It's wherever you would like. And that's really a different property. Source control history, I think, is also an important difference. And this sort of speaks to how software lives. Of course, an author could write a book and have source control, and they could even publish that if they wanted to, but that's not critical to your understanding of that piece of literature. But in software, often knowing something about the history of a piece of software is critical. So you're going to have a different look at a piece of software if it's been being written for 20 years versus it's only been written for a year. And if you're trying to understand why it's in this certain state, you may be looking back through time to see how people got there. And I think it's just really different than kind of how normal literature is. Also, software is software is often collaborative. I think more often than not. I've written software by myself. No one's ever seen it before. Authors have written books together. But, again, especially here professionally, we all work on teams with each other on the same software base. So that's really different than the kind of normal idea. And I think it's important to keep that in mind as you're reading, because what that really means is you have a number of authors, and you have a number of authors through time. And if you take that perspective with you, that's a real difference for you to be thinking about when you're thinking about code reading. So, like I said, I took a lot of intuition from kind of where educators were thinking about things. So we're going to take a look at some strategies that educators use to talk about reading comprehension. There's all sorts of lists like this out there in the world. This is one I like. Okay. Hang on. Okay. I really like this quote. Real comprehension has to do with thinking, learning, and expanding a reader's knowledge and horizons. If you kept this in mind as you were struggling through a piece of code, you're like, I'm thinking, I'm learning, I'm expanding my horizons, you would have a way better, different perspective on reading code than, oh my God, this is the worst thing I had to do all day. Anyway, so we're going to talk about some strategies. Creating, and think about how these relate back to software. Creating mental images. Good readers create a wide range of visual, auditory, and other sensory images as they read, and they become emotionally involved with what they read. Use background knowledge. Good readers use their relevant prior knowledge before, during, and after reading to enhance their understanding of what they're reading. I mean, that's so critical. Like, if you think about that statement, you know, your background knowledge that you bring to the table not only helps you now for reading, but it helps you for the next time that you come around for reading. Ask questions. Good readers generate questions before, during, and after reading to clarify meaning, make predictions, and focus their attention on what's important. You know, that's so hard for, you know, software. I think software is kind of harder to read than literature in a lot of ways. But, you know, this is a great strategy to, you know, start asking questions and refining them. Predictions. We don't talk about predictions, but we do that we do that regardless. You're starting to read something, you're guessing ahead. What's the next thing I'm going to see? Make inferences. Good readers use their prior knowledge and information from what they read to make good predictions, seek answers to questions, draw conclusions, create interpretations that deepen their understanding of the text. Determine the most important ideas or themes. Good readers identify key ideas or themes as they read. They can distinguish between important and unimportant information. I mean, when you're thinking about reading software, the ability to distinguish between what's important for your task and what's not. You know, in my sitting next to good readers and good code readers and watching them, that is always amazing to me, how they can kind of just cut through the BS in a code base. Synthesize information. Good readers track their thinking as it evolves during reading to get overall meaning. I like this last one a lot. Use fix-up strategies. Good readers are aware of when they understand and when they don't. If they have trouble understanding specific words, phrases, or longer passages, use a wide range of problem-solving strategies, including skipping ahead, rereading, asking questions, using a dictionary, and reading the passage aloud. Like, we reinvented some of these ideas already in coding, like talking to the duck. You know, it's like, but like all these ideas have already been thought about, you know, for a long time in education. All right, so another list. Strategies for reading comprehension. This one comes from Scholastic. That one was from a book. Activate prior knowledge and connect the applicable prior experiences to the reading. If students don't have the requisite background and knowledge about a topic, they will be unable to comprehend. Think about that in terms of onboarding. Like, we onboard somebody to a project. It doesn't matter if they're new to Brightcove, if they're new to your team, you know, they're not going to have that background knowledge. They will not. We are putting people at a disadvantage when we don't properly give them really great background information. Set purposes. Do prediction. Summarize. Bring meaning forward throughout the reading, building on prior information to create newer and fuller meanings. Reflect on and apply the meaning that has been made to new situations. And again, this last one I like so much. Monitor understanding. The most salient differences between good and poor readers is that good readers know when and often why they are not comprehending. A lot of these lists that I read through are really similar. The themes are very similar. Ability to predict, asking questions, setting purposes, knowing when you're doing a good job and not doing a good job of comprehending something, and having good background information. So there's a couple of strategies that I wanted to point out that I do not think apply to literature, but are important strategies for reading comprehension. And we're going to talk about tactics differently. So I'm splitting these up in between tactics for code reading and strategies. So understanding the domain of the application. You could argue that that's background knowledge, but I think there's just, it's something so core and such an important word that we use as an industry, that I thought it was important to call that one out itself. Attempt to categorize the architectural patterns. So, knowing kind of generally what the structure of this thing is that you're looking at. Learn about the history of the code base. I already talked about that. Knowing that this thing's been worked on for 20 years is really different than, knowing that it's greenfield or it's a year old. And do you know the frameworks involved? Often that can really give you a lot of different kinds of insight about that code base. Is it Spring? Is it Ruby on Rails? These things are important to how programs are structured and will help you work through them from a strategic level. So this is kind of the big list. I'm not going to read it, but this is like everything smushed together that I've talked to so far. Something that I learned from a lot of the research I did is people like to take these up and make small lists of them because you can't remember everything otherwise. So that's a job for somebody else. I want to talk about tactics. If you're trying to tactically comprehend code besides those big strategies, there's all sorts of different tools and tricks that we use to try to understand code. And so I'm just going to zip through these. So finding an entry point. So like I said before, where is a good place for you to start reading? Can you build the code? Can you run the tests? What's the directory hierarchy look like? Have you zipped through the source control? What's the documentation look like? Just go ahead and start refactoring it. Your reading and refactoring can go hand in hand. Have you done any diagramming? There are like 15 different types of UML diagrams. I don't use very many of them. I like sequence diagrams, but there's all sorts of different ways to talk about what the structure of code is and techniques for diagramming it. Debugging, that's a great tool. You execute it, set a breakpoint. What's the stack look like? Where are we? How did we get here? Just break the code, Does an error get thrown the way that I think it should get thrown? What do the class hierarchies look like? What's it like if you start the application? Can you start it? And another one that I think is really interesting is how are the instances wired up? So if you're in an OO world, yeah, you may be dealing with an interface way deep down, but you don't know which type that instance is. So finding that place in the code where it's concrete. It says this is a foo basil factory instead of just a foo factory. I don't know what the rest of this list is, but it's huge. The tactics here can go on and on. So back in 2012, as far as Software Craftsmanship Group, we did some. That's when I started thinking about this. We workshopped this, and now they've learned more about kind of code reading strategy, reading comprehension. Thought of a different way to workshop this. If anybody is interested in workshopping this, I'd be up for running this. So pick a code base, pick a question. Like, what are the big concepts? That's what we did. We read JUnit and JBehave and did a little comparison between the two. What are the major domain ideas? Pair up, assign a set of tactics and strategies to different pairs, and then see how far those groups of people can get with just trying to stick with those ideas. Report back to the group, and then talk about what other strategies and tactics you came up with. I just want to say something about, why isn't code reading comprehension focused on? Because it's not. It's not something people talk about. And I think that's because it's hard and challenging. I think the perceived value is low. But I think to be an effective coder, you need to be an effective reader. And the better a reader you are, the more code is accessible to you. And I think there's no greater disservice we do as an industry today than failing to teach code reading comprehension. So here's some resources. I can send this out if folks are interested. I wanted to end with a final quote from an academic researcher. And I'm going to read this even though it's long. Comprehension, in contrast, is not a skill. It's a complex of higher level mental processes that include thinking, reasoning, imagining, and interpreting. Comprehension is difficult to teach because these processes are domain or content specific rather than domain or content general. That's why the best predictor of comprehension is familiarity with a content domain, not strategy-based instruction as many people believe. Familiarity with the content of a passage is in fact so important that poor decoders do better than good decoders when they have more knowledge of a topic. Because comprehension is knowledge dependent, instructional approaches that target general strategies will have limited impact on measures of reading that include diverse content domains. And really my final thought is this a metaphor or not? Is the Scarborough-Rote model a metaphor for how we should be thinking about code reading, or is it actually informative of how we should be? I think, you know, basically, is code so different from literature that those ideas don't actually apply? They just sound like they do. I don't know the answer to that, but you know, I hope that this is picked up in the industry and educators and researchers start to ask these questions. That's my talk. Any questions?
So when you talk about this, is documentation play an important role into that? Like in the code reading, if we have links to, say, the prior knowledge, right? So if we have something that we kind of solve in the code, kind of link to that ticket, or maybe write it in the code, would that help to the whole comprehension?
So the question was, let me see if I can repeat this well. How important is documentation to comprehension?
Inside the code, yeah.
I think documentation is really important. You know, I think both from a background knowledge perspective, but also just as a, you know, as a tactic for when you're diving into a piece of code. You know, what does the documentation say? All right, let's see. Cool. Any other questions? Anyone wrote? All right, cool. Well, I zipped through this way faster than when I gave the talk, so thanks for your time.